Hi, welcome back. In this video, we will be talking about using UCSs along with orthographic projections to be able to draw either elevations or sections through our plan in the most efficient way possible. To begin with, I'm going to talk a little bit about how you might have done orthographic projections before using the plan. Typically, when you first learn orthographic projection, what you probably would have started with is a plan of some object. In this case, we're using a floor plan. And if I were to draw, let's say, an elevation of this side of the building right here, I might have started with drawing the ground plane, and I would have started by then projecting certain aspects of the plan, like the corners, where my openings are. Right? Other parts of the plan, door openings, another window, and the other corner. And just like any other orthographic projection, like an elevation, we're not concerned with the sides, right? Because this is a true elevation. We're looking at this straight on, not in perspective, but straight on. So we see only the faces that are directly facing us and the ones that are perpendicular to us, and certainly the ones that are behind the building, we do not see. So these are all the corners and important aspects of the elevations in which we are projecting down to our ground plane. And some of these lines are a little bit short, so let me just stretch them a little bit like that. Okay, so if this is our ground plane, and let's pretend this is a one-story building, and the next thing we would do is offset this line to a height of whatever the height of the building is. So let's just say for discussion purposes, the height of this is 10 feet. So I will type 10 feet, hit enter, select this object, and offset that. Okay, so I could start to trim some of this. I could either use my trim command, TR, and trim some of these lines. Oop, wrong one. This one. Draw a line all the way across and trim all of those. And same for these lines here. Okay. Next, I will locate these windows. And so the plan location, I've already projected from the plan because I have the plan already drawn. And the only other thing I need to do is locate the vertical dimensions of these windows. So let's just say for discussion purposes, these windows are 36 inches off the ground plane. So offset 36. All right, and let's say the windows themselves are 5 feet tall. So I will offset again and offset 5 feet. And so that is the locations of my windows vertically. And my door, let's say my door height is at the top of the window. So that's 3 and that's 8 feet, right? So now I can start to trim some of this information so that I can clean up the drawing and get a sense of what it is I'm actually looking at. So these are windows, so I will trim around those. Right. This line here represents the corner, so that does not get trimmed because that will go completely vertical from the ground plane up to the roof. This next line is the edge of the door, so that will get trimmed up here at the top of the door. This line doesn't exist through the door, right? Because the door is from ground to the height of the door. This gets trimmed, this gets trimmed, that gets trimmed. This is the edge of the corner of the building, right? That edge right there. And this edge here, this line is the jamb of the window. So for that, I will trim that, this, and these as well. And all the lines that are extending outside of that, I can erase. So with that, that's the essential basic projection of this elevation. Now I can come in here and draw all the additional details like the window frame, the mullions, the sash, trim on the top. Maybe there's a base here or whatever the material is here on the facade, which could be brick, clapboard, stone, whatever the case may be. The door handle, the frame, so on and so forth, right? Also, you've noticed, which we'll talk about in another video, the layers in which we should be using. Right now, everything is drawn on a viewport layer, which is not correct because we're not drawing elevations on viewports, but we're going to pick just layer 0 for now until we get to the point where we're talking about layers. And so that's one elevation of this building, and it's projected. And that's how you probably would have learned how to do projections. Now, the next part, which is that what if we wanted to draw this elevation, the elevation that's on this side of the building, right? Looking at the view cube, that's the east side of the building, right? So if we wanted to draw the east side of the building, what you might have learned how to do is take your plan, select all of the objects in your plan, copy that over some distance, and you might have rotated this 90 degrees so that the east side is now facing it's aligned with the X and Y axis, right? So normally the east side would have been aligned with your Y axis. Now that we rotated our plan, it is now, the east side is now parallel to the X axis, okay? And if we were to do this, it would be very similar. We would project all the lines from the corners, just as we did before. We can extend this line, which is the ground plane. We could extend this line, which is the roof plane. We might even extend the lines of things like the head of the window and the sill of the window, and continue to project all of these lines of, again, the important features of the building. So again, the corners, the door and window openings, right? And we would have, this line is snapped to the wrong location. So let's go back here. And again, at this point, we could start trimming this and having it look more like an elevation. Right, and these are our windows. So we will trim around that and trim around that. So we have a cleaned up version of our elevation. Is this a window? Yes, that is a window. And I'm just going to extend this ground plane a little bit out so it is in fact ground plane. Oh, and there's a line, there's a couple of lines I got rid of that I shouldn't have, which is this line here. Oh, that was not a window, so I accidentally trimmed that, right? So these were not windows. These should have been extended to the actual roof and baseline. So there's only two windows on this side that we would see. So we would have done that. Just change all of this to layer 0, just so it's all solid lines, right? And then if we were doing the next one, we would do something similar. Copy this, rotate this to the north side. And then if we wanted to do the west side, we would copy this yet again. And we would rotate this one more time to get all 4 of those elevations to be parallel to that x-axis. And then we would have 4 separate little elevations that are parallel to those plans. And fundamentally, there's really nothing wrong with that. The only issues with that is that it really becomes a little bit inefficient. And what I mean by that is, let's say, for example, in this plan, which is our original plan, let's say we decided to make this window smaller, right? That's actually not, that in general, that would affect this elevation. It doesn't really affect these elevations per se, But if you notice, the plan does not change when I change the size of this window. So that means if I wanted to have these plans accurately represent what was actually the current state of this plan, I would have to revise this revise this plan to show a smaller window here. I would have to revise this plan to show this smaller window here, and revise this plan to also show a smaller window here. So I'm taking that one window that I changed and having to modify 4 separate plans. Now that's not such a bad, revision to have to do 4 times. However, if there's something really fundamentally different about the plans, for instance, if I change this, whatever that is, right? That's some steps, that's overhang, whatever it is. Let's say I do something really drastic here, right? So now I have to change that same thing here once, twice, 3 times, 4 times. And in that case, that shows up here in this elevation. It shows up in this elevation. It shows up not so much in this one, but it actually may show up in this one. So in those cases, I will have to change all 4 elevations and all 4 plans in order to be able to project those down to my sections or elevations. So that makes for a little bit more work. And those are fairly simple revisions. Sometimes revisions on a plan are much more onerous and require a lot more time to make those revisions happen, especially if it's across 4 plans. Now, not every drawing you have will have 4 elevations to draw, right? Not every drawing you have is essentially rectilinear, like a rectangle or a square. You might have a drawing that has multiple sides. What if it's a hexagon? What if it's an octagon? What if there's multiple sides to a building in which you need to rotate the same plan several times, not just 4 times? Now you're talking about a lot of drawings that you're going to have to revise, and also revise the elevations and reprojecting the lines. So what we're going to do now is I'm going to show you a way of using your UCSs or your UCSs, which you should have watched in the previous video, and to rotate that UCS around the plan, and we can change our view to rotate around the plan so that we are only using one plan to project all of our elevations or sections. And what you'll see is that those elevations and sections will be rotated around this plan so that they will all be parallel to the faces they're referencing. And then when I make a change, I'm only changing it once, and I could just reproject the components that I need to reproject. Okay, so to begin with, I'm going to leave this here, just floating here for now, and I'm going to copy this elevation up here. Oop, not move, I'm going to copy. Okay, so that's going to exist up here. So if you watch the previous video, we talked about the world UCS and the UCS, world coordinate system, sorry, and the user coordinate system. The world coordinate system is always parallel, X and Y, to your current view, right? If we're looking at the view cube, north is always up, south is always down, east and west is to the right and to the left. And what we can also do is take that UCS and we can move it. And if we move it to another location, let's say here, it becomes a user coordinate system because I moved it, right? The UCS is always, the WCS is always oriented the same way, regardless of what happens. Once I move it, it becomes a user coordinate system, a UCS, because I changed it, right? So for this first elevation, no real change. Even though I moved this UCS, it's still parallel to my world UCS, right? So there's really no change in that. So if I take this UCS and I actually, let's say, place it on this side, okay, where you actually place it really doesn't matter for what we're doing here. I just like putting it in a place where I can see it. So I will put it here, and now I will select the grip on the x-axis, and I will drag it vertical, making sure my ortho is turned on by pressing F8 or coming down here and turning on ortho and orienting the x-axis vertical now, so that the x-axis is parallel to the side that I want to draw. Okay, and the y will be pointing to the left. Now, again, normally the x point is usually oriented horizontally at the bottom and pointing to the right. And now this is pointing vertical up. Okay, so what I'm going to do now is either I'm going to rotate my view using these arrows here, or I could type in plan and select my current UCS to make my current view parallel to the current UCS. So one way, again, I could rotate this so that my plan is then rotated and oriented to my current UCS. Now, did I have to rotate my plan? I know it looks like it's rotated, but it's not. It's rotated relative to my UCS. It's still exactly the same relative to the world coordinate system, right? So before, the north was pointing vertical, was at the top, and now north is to the right because I rotated it, right? So it's always remaining the same, except now I changed my view to be parallel to the current UCS or my user UCS. So once I do this, right, and let me move this over to the side so it's out of my way. Now what I can do is I can draw a ground plane here, right? And what I'm going to do also is I'm going to extend my ground plane from the previous elevation so that it intersects this ground plane as well. And I'll tell you why that is important, okay? So now what I'm going to do is set up this drawing so that I'm drawing my elevation so that it's parallel to the side of the plan, right? And again, because we're projecting it, anything we drew in plan already, all we need to do is project them. We don't need to recall the dimensions of these windows. We don't have to look it up on our survey. It is already drawn in the plan, assuming you drew the plan accurately to begin with, right? So all I would need to do is take these lines, just like I did before, and extend them down to the ground plane from these points, right? Again, wherever these points are is where we're projecting our lines. Okay. This line, and right now we're just drawing elevations. This is the same thing when it comes to sections. It's just that for a section, we will be cutting through the plan and removing everything that we wouldn't be seeing, okay? So if this is the projection of this plan, right, for this elevation, what we would be doing now is offsetting this line up to the roof line. Now, we could just offset that. If we know that dimension, we could just offset it very quickly, and that's fine. If your drawing is a little bit more complicated and there's much more vertical information that we need to project and offset up from the ground plane, what might be easier is actually drawing a line from this intersection of the two ground planes at a 45-degree angle. And what that allows us to do, and let's do that right now, from this line, I will draw a line that is approximately 20 feet, direction 45. Okay. So now I draw a line that's 45 degrees from the intersection of this ground plane. Now, what that allows me to do is not only project information from the plan, it will allow me to project information from the adjacent elevation. Okay, so we measured before the height of the sill, the height of the window, and the roof line. Okay, so we really don't need to offset those same dimensions from here if we've already done it once before. Now, this is a fairly simple drawing, and there's only a couple lines that we would have to do this, but most drawings are going to be a little bit more involved. So for here, what we're going to do is project from this elevation down to that 45-degree line. Same thing with this point, down to the 45-degree line, and down from the roof line to the 45-degree line. Once that line hits that 45, and let me trim this just so it's a little bit clearer, right? We can project these across my elevation this way. And that 45-degree line allows you to kind of turn the corner, right? So it comes down, 45, comes across. So once those lines are projected down to the 45 and across, now I have basically all the information I need to trim this out so that I get the basic outline of this elevation. And I haven't had to measure anything. I haven't had to offset any dimensions. Everything is coming from either the elevation or the plan. So I can come here and trim all of this like that, like that, like that. And this is the first window, so this one will get trimmed. And these lines do not, oh, need to trim this one. These horizontal lines because they're not important. And here we're going to trim this window here. Right, and let's change this to layers of rows just so they're solid lines. Right, so that is my next elevation. Okay, now again, I would do this similarly to the other side. I would take my UCS. I could move that to a location that is convenient so I could see it. Let's say about here. Let's put here. And then I'm going to rotate this again, ortho on, 90 degrees. And this time I'm going to use the plan command. Plan, enter, current UCS. And now it rotates my plan to be parallel to that UCS, which is then parallel to this side of the plan. Now, again, draw my ground line, right? I could trim this, okay? And then I'm going to draw the same thing, the 45-degree line. This case, because I've drawn it once, right? Yes, you can draw from this, but I'm going to mirror this from here to, or from the midpoint here to there, and it plops it right where it needs to be. Again, same idea. Project this line to the 45, project this line, right? And then you could trim this out so that it's easier to see. And then again, project this across, selecting the wrong spot. There we go. Again, exactly the way we did it before. And I'll just project these lines, but I won't finish the elevation because I think it's pretty clear what we're talking about. Okay. So that is the next elevation, and I would just continue on and to the other one. Okay. Now, the beauty about this, again, if I return my UCS world, W world, I can rotate my plan to be parallel to my world again. Now, if we look at how this is set up, yes, the elevations are rotated around and relative to each other. This is sideways, this is upside down, and the next one would be sideways, right? But they're rotated around one singular plane. So if I make a change here, I can simply just reproject these lines to modify my elevations around, right? If I did it this way, where I'm copying the plan multiple times and rotating it around, I would have to make those changes several times and reproject everything. The more times you do something, the more likelihood you are, or the greater chances you have at making a mistake, right? I can't make a mistake here. I change it once, that's it. The only mistake I can make is if I don't project the revisions down to my elevations to reflect those changes, right? So it makes the drawing smaller. It makes it much more efficient. It's very clear as to what elevations are what because they're oriented and parallel to the faces that they're drawing. And it just makes for a much cleaner drawing. Okay, so that's how I would like you to proceed with your elevations. Okay, is to try to change your UCSs around so that they're parallel to the sides that you're drawing, and then you will draw the elevations around them. Now, again, like I said before, if I were to draw a section elevation, which is what you're doing for your assignment, right? You're essentially having this drawing right? And basically what you're doing is taking an area that is defined by that section line, like pretend this dotted line is a section line, and taking this whole area here, and let me drop a hatch in here. Select the object, right? Taking that object and you cut that section, and all of this information that's here, that's beyond the cut line, you won't see. So you will see everything here from this cut line up to this elevation. All right. So you would see the entirety of this elevation of this wall, the entirety of this wall. You will see all the objects in front of the wall. Okay. And you will see these walls that are cut, and they will be a much darker line weight. All right. So that's the only real difference. So this would be parallel here, right? If you're cutting a section the other way, if you're cutting a section this way, let's say, right, you will draw that elevation or elevation section here. Okay. So now that we have these elevations drawn around this, the next question you might be asking is, well, how do I put this in my viewports, right? Now that they're rotated around. And that's a fairly simple thing to do as long as you understand this idea of UCSs, right? So if I were to go into my layout tab, um, and I could create a new layout tab just so I have a viewport set up for me, right? And it doesn't, again, you would set up this with the correct title block and the correct page setup and things like that before you would set up your views so that you knew how much area you have to work with, right? So here in this case, pretend this is set up the way it's supposed to be set up. If I activate my viewport, I could zoom into one of these elevations, right here. And let's pick a scale that we think might work with these viewports. All right, let's try that, right? So let's say that's one view, right? And let me trim this down a little bit. And okay, so then that is here and here. So let's say that's one elevation, okay? Let's just put that here so we have a little bit more room. Now we're going to take this viewport, right? And let's, in this case, let's make it bigger just so we could see what's going on. Okay, so viewport is exactly the same, looking at the same exact area. So if I activate this viewport by clicking inside of it, I can pan this to my elevation. And of course, my elevation is sideways, right? Because that's my UCS, right? So what I can do is, again, I can take my UCS and I can rotate that UCS, right? So that the UCS is now parallel to this elevation. And then I can take my plan command, set it to my current UCS, and it will rotate my view so that it's parallel to this elevation. Then I could zoom in, set the zoom, the scale of that to, was it 1/8 of an inch? No, it was smaller. There was 16. Okay. And again, change this viewport so that it crops into the area that I want to see. Right. So if I did this again with the other one, so this is both my elevations, right? Again, and then I would do this for the third and the fourth or however many I have. Now, for all intents and purposes, when I'm looking at this drawing, all my elevations are parallel. The ground plane is at the bottom, right? The roof line is at the top. That's the way it's supposed to be oriented. But when I go back into my model space, they are still oriented around the plan. So if I were to make changes here, let's just say I'm going to put a big old X right through here, just so that you can see that there's changes happening, right? Change, right? Then if I go back to my layout tab, those changes exist in real time. And I don't have to rotate my views anymore. I don't have to change any of my orientation. If I make a change here once, I make a change once and it shows up where it needs to show up. Okay, so that's much quicker than if I were to make a change here, having to change it here, having to change it here, so on and so forth, making that change possibly 4 times or maybe even more, which would, again, add time to completing this drawing. Okay, so just to recap, using your UCS, right, which you should have viewed in a previous video, we could rotate our UCS around our plan, orient our view, either using the arrows here by the view cube or typing the word plan and having it parallel to the current view, the current UCS, and then just rotating that view around the plan so that we can project from the plan, but also project from the adjacent elevations through the use of this 45-degree line, right? So that we can minimize how much we're remeasuring, how much of the dimensional input we need to put in, because if we've inputted it once, we could just use it again, and that will increase your coordination accuracy of all of your drawings. Once we get those elevations drawn, we could bring those elevations into a viewport. We could rotate our UCS, orient the plan to that UCS, and then rescale the viewport so that we can fit what needs to be fit into those viewports. And you would do that around each plan so that you can see all of the elevations you need to see. Okay, so with that, hope you will find that useful in drawing your elevations. And again, together with the UCS, WCS video, hopefully this will make drawing elevations and orienting them into viewports in paper space will be helpful to you. Okay.